You're welcome to Dynamic Educational Hub channel. Your answer to the very question. Now, this is a channel where we learn various topics in physics, chemistry, and mathematics. If this is your first time of coming across my channel, kindly subscribe to my channel and click on the notification icon in order to get notified when I release new video like this. What are we learning in this video? We are learning method of solving simultaneous equation. When you have some set of linear equation, method of solving it, and we are going to focus mainly on Gaussian elimination method. Solving simultaneous equation using matrix, that is what we want to look at. Now we have method. The first method is we have Gaussian elimination method. You can use Gaussian elimination method to solve simultaneous equation using matrix. You can as well use determinant method, which is also known as Cramer rule. You can also solve it using inverse method. So let's look at Gaussian elimination method. Now Gaussian elimination method is a row operation in which you are performing simple addition, subtraction, and scalar multiplication to reduce the augmented matrix into triangular matrix. I'm going to explain this. Don't forget, I explained triangular matrix in my first video. In this playlist, the first video in this playlist, I've explained triangular matrix. Now, Gaussian elimination method is coming from the fact that if you have a linear equation, you can write as many infinite equations from just a single linear equation. You can form as many infinite equations as possible. Let me explain it further. Now let's say this is a matrix, and what is augmented matrix? If you have linear equation, you can pick the coefficient of the unknown and write it out. That is, when you write the coefficient of the unknown out and the answer out, you are going to have an augmented matrix. For instance, let's have this equation: a1x plus b1y plus c1z is equals to e1. Let's call it equation 1. And we have this as equation 2. We have this as equation 3. Now this is 3 unknown equation. Let's see how to solve it. The first thing you want to do in Gaussian elimination method is you have your augmented matrix. Let's look at the augmented matrix. Here in this equation, we are using x, y, z as unknown. So you write out your x, y, z. Then you write out your answer as well. What did I mean? The first equation, just compare it. Look at it. The coefficient of x is a1. You have it under x. Coefficient of y is b1. Coefficient of z is c1. And your answer is e1. So for the second one, coefficient, we have written it. And that is how to form augmented matrix. For this one, we have written it. Now let's carefully look at our augmented matrix. For x, you can see that we have a1, a2, a3. That is what we have here. For y, we have b1, b2, b3. And for z, we have c1, c2, c3. And all our answers, we have it here. That is augmented matrix. That is the first thing you are going to do while solving equation using matrix method, using Gaussian elimination method. Now the concept of Gaussian elimination method is the other one. If you can find a way of reducing this augmented matrix we have here, which means the coefficient of the unknown that you have done to augmented matrix, if you can reduce it and you manipulate your equation, you do an operation either by simply addition, subtraction, multiplication using scalar multiplication, and you subtract the equation, you perform various operations like addition, subtraction, and you're able to get new set of equation in which you have the coefficient of the unknown here 0, 0, 0. That means you have triangular matrix. So it's either you have it in this form, or you have it in this form, or you have it in this form. You have up to 12 form. You can have it this way. You can reduce the augmented matrix to this type of augmented matrix, you can actually solve your equation using back substitution. What did I mean? If you have new set of equation in which you have reduced one of the following to this format, let's say you are only left with z while the other one has 0, and the other one you're only left with y and z while x is 0, and the first equation or any one of it, you can do back substitution. Using back substitution, you can now find the value of the unknown. An example will make it clearer for you. Now let's say you have this equation now. Example, find the value of x, y, and z in this set of equation. We have 3 equations here, simultaneous equation involving 3 unknowns. You don't know the value of your x, y, and z, and you want to find it. Let's see how to find. This is your equation. The first thing is you write out your augmented matrix. You have your x, y, z, and your answer. For x, we have 3, for y, 2, for z, 4, for your answer, you have 3. That is for the first equation. For the second equation, you have 1, 1, 1, 2. For the third equation, you have 2 minus 1 plus 3, 3, and minus 3. This is your augmented matrix. Now let's carefully observe it. Now the next thing you want to do is you want to perform your row operation. You want to perform row operation. To perform row operation, the first thing which you will do is you are going to choose a starting point. And what is your starting point? Which means you are going to choose a row. If you look at this, you should be careful while choosing a row. You can choose anyone you want to start with, but for me, I want to choose this second row because I have 1, 1, 1, 2 here. So I'm choosing it as my starting point. I pick it. Now the next thing is, if I multiply that row by 3, so multiply row 2 by 3, let's see what I'm going to have. Why am I multiplying it by 3? I want to multiply it by 3 so that the coefficient, the x here, will be 3, 3. I can subtract it so that I will be left with y and z. So let's multiply it by 3. Multiplying it by 3, you are going to have 3, 3, 3, 6. The next thing, subtract row 1 from it. So if you want to subtract it, it means that row 1, every element of row 1 like this will have additive inverse since you are subtracting it. So it means that this one will carry minus 3 minus 3. This one will be minus 2. This one will be minus 4. This one will be minus 3. So this is, we want to do this operation now. This one minus this one. Subtracting it, what are we going to have? For this one, we have 0. 3 minus 2, we have 1. 3 minus 4, we have minus 1. And 6 minus 3, we have 3. There we go. We have reduced one of this equation to something like this. One of these elements, augmented matrix, we have reduced it to this. Now what are we going to do next? Let's have our matrix here, initial augmented matrix. So what are we going to do? We are going to replace that one with the new value that we have gotten. Then the next step is we want to reduce this one. Let's reduce the third row. To do that, we are still going to use the second row as the basics. Now to do that, why am I even choosing this second row? Now let's observe it. Let's observe something here. So choosing this second row, if you multiply it by 3, subtracting it from this one, you can get this. Multiply it by 2, subtracting it from this one, you can as well change this one to 0. That is why I'm choosing it. So we've done it for the first one. Let's do it for the third row. Now to do that, multiply row 2 by 2. When we multiply it by 2, you are going to get 2, 2, 2, 4. The next thing is subtract row 3 from it. So this row 3, we want to subtract it from this one. Because you are subtracting it, everything here will become additive inverse. So we are going to have what? Minus 2. This one will be minus, that becomes plus. Plus 1. This one is minus 3, and this one is going to be what? Plus 3. So let's do the operation. 2 minus 2. I'm doing it this way so that you will not be confused. Do it this way due to the fact that you are subtracting. So you can do it this way so you will not be confused with sign. So if you are subtracting, you do additive inverse. Now let's go. 2 minus 2, you have 0. 2 plus 1, you have 3. 2 minus 3 minus 1, and 4 plus 3, you have 7. You see, the x here has turned to 0. What are we doing next? We are replacing which row? Third row by this. We are not yet done, so we still have an operation to perform. And what is that operation? We want to make sure that it's either we eliminate, we turn this 1 to 0, or turn this 1 to 0. But in order to form triangular matrix, we are going to turn this 1 to 0. You can as well do it that way. It does not mean you will still get the same answer. Now let's go. I will choose this one again for the second row. I will choosing it the second row in the new augmented matrix. Why am I choosing it? Multiplying it by 3 and subtracting them will make me to turn this guy to 0. So let's multiply it by 3. Row 2, multiply row 2 of the new augmented matrix by 3. So we are going to have 0, 3, minus 3, and 9. After that, subtract it from row 3. So this is row 3. I want to subtract this one from it. Don't forget, it becomes what? Additive inverse. So you have 0 minus 3 plus 3 minus 9. So you do the additive inverse. 0, 3 becomes minus 3, minus 3 becomes plus 3, and 9 becomes minus 9. That is what we have here. The next thing is, let's do it. 3 minus 0 plus 0, 0. 3 minus 3, 0. Minus 3 plus 3, minus 1 plus 3 plus 2 or 2. 7 minus 9. That will give us minus 2. So it's going to replace this one. Now we have this. If you look at this side, it has formed a triangular matrix. Now what are we now doing next? Don't forget that we use this one to get this one. So we can use this one to get new set of equation. From my explanation, that is just Gaussian elimination method. You just use your row and perform some simple operation and reduce it. We start writing new set of equation from the new augmented matrix. So we can replace the augmented matrix and turn it into equation. The first one you are picking is the last augmented matrix, the last row, and it's going to replace the last equation. Thereafter, we move upward and pick the next row, and it's going to replace the second equation. Then we have new set of equation. With this new set of equation, is it not easy to solve this one? This one is very simple, and you can solve this one starting from z. Solve the last equation and do back substitution. Let's solve the z. To solve it, divide both sides by 2. So our z is going to be 2 over 2, which is equals to 1. And because of this minus, you have minus 1. So you have gotten the value of z. You can move higher a bit and do back substitution. Just substitute the value of z in the second equation. So you have y minus, what is z? Minus 1 is equals to 3. When you solve that, you have y plus 1 is equals to 3. Minus times minus is plus. Do that, y is equals to what? 3. When you transfer this plus 1 to the other side, you're going to get minus 1. That is one thing about mathematics. If you are struggling with linear equation, there's no how you will know this. This is simple, and it's quite simple. So y is equals to 2. The next thing is, we have gotten the value of y and z. Now let's go ahead and substitute the value of y and z in the first equation here. So that is what we want to do now. To solve that, we have 3x plus 2. What is the value of y? 2. Plus 4. What is the value of z? Minus 1. is equals to 3. Let's solve that equation. 2 times 2 here becomes 4, plus 4 multiplied by minus 1 it becomes minus 4 is equals to 3. Plus 4 minus 4 it becomes 0. So you have 3x is equals to 3. Divide both sides by what? By 3. So you have 3 divided by 3, which is equals to 1. So find the value x, y, and z. X is equals to 1, y is equals to 2, and z is equals to minus 1. So I've solved this equation using Gaussian elimination method. To check if the answer is correct, let's plug in the value into the equation. First one, 3x plus 2y plus 4z is equals to 3. Then we are going to have 3, then we have open bracket 1 plus 2 open bracket 2 plus 4 open bracket minus 1. If you solve that, we are going to get 3 plus 4 minus 4, and that happens to be 3, which means that one is correct. The second one, we have x plus y plus z is equals to 2. So let's plug in the value. So we have 1 plus 2 minus 1, and that will give us 1 plus 2 is equals to 3, 3 minus 1, and that will give us 2. Lastly, we have 2x minus y plus 3z is equals to minus 3, and we are going to have 2 open brackets 1 minus 2 plus 3 open brackets minus 1, and if we solve that, we are going to get 2 minus 2 minus 3, and that is going to give us what? 2 minus 2, that's 0, minus 3 minus 3. You can still solve this same equation using Gaussian elimination method by taking another route. You can decide to subtract equation 3 from equation 1, and the new value that you have gotten, you can subtract it from equation 2. You can use that approach as well. We have many routes, many approach in Gaussian elimination method. Just use the one that is convenient for you and the one that will not take much time. This is the first part of this video. The second part, I'm going to solve more examples on Gaussian elimination method. Thanks for watching my video. Comment if you are going to solve this. If you solve this same equation using another route, comment in the comment section, like my video, share my video, and see you in the next video. Thanks for watching. Bye for now.